Okay, 6.3 is over medians and altitudes of the triangle. So we're going to talk about our last 2 points of concurrency today as well within this. So in a triangle, a median is a line segment with endpoints that are a vertex of the triangle and the midpoint of the side opposite. So you can take any triangle and draw yourself a median, but you do need a triangle to draw that. So you find the midpoint of one side, so those are split, and the vertex that's opposite, and you connect those, and that's a median. And there are 3 medians of each triangle. Okay. Every triangle has 3 medians. They are concurrent. The point of concurrency of those is called the centroid. So where all of those medians intersect is actually called the centroid of those. So making those connections there. The other thing it says here is it is always inside the triangle. This is something that will come up in our homework, so we're going to be talking about that. But the centroid is always inside the triangle. So the centroid theorem says the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So this is something we are going to use to solve information with that, but it's 2/3 of the distance from the vertex to the midpoint of the opposite side. So wherever the centroid is, it'd be right about here on this picture, is that from the vertex here is 2/3 of the full distance across, okay? Or what we are going to talk about is that if this is like 2x, then this is x. Those kind of ideas, it says double the short part. All polygons have a balancing point or center of gravity. This is the point at which the weight of a region is evenly dispersed and all sides of the region are balanced. The centroid is that center of gravity. So that center of, or that balancing point is what we're talking about here. That balancing point here, or center of gravity, is actually the centroid. So if you make a triangle that is sturdy and you find the centroid of it, you will have a point of balance of that triangle. Okay, so how could you find the coordinates of the centroid of this? So let's think about when we see centroid, we should think make medians and make midpoints and connect to the opposite vertex, which is making medians. So here you can see that one is done for you from S. They connect to the opposite vertex, and you have that. So what you're going to have to do here is do a median of another side. And it doesn't matter which side you do. You don't have to do all 3. You can to check. But we need to find a midpoint. So let's say a PR here. If I'm going to find a midpoint of PR, I'm going to look at P that's at 2, 3, and I'm going to look at R that is at 5, 7. And the midpoint is going to be the x's added together, 2 plus 5 divided by 2, which is going to be 3.5. And then the y's, 3 plus 7 divided by 2, 10 divided by 2, which is going to be 5. So the midpoint's going to be at that. So if I go to 3.55, that's the midpoint. And I'm going to connect that midpoint to the opposite side there. I want to do this straight, so I'm going to go ahead and use this here. So we're going to connect from there to there. And that's what we are going to get out of that. If you're not sure, you can do the third one, but that's all you have to do to find it. And so if you're trying to find that centroid, that's what you're going to do. Find the coordinates of the point that is 2/3 the distance from point R to S, or you can find the intersections. So that's where you would be. I believe our centroid would be right there. We can actually check it with that 2/3. So this distance is 1.5, and this one is 1, 2, 3.5. So we're not quite there. It actually would be a little bit up in here, a little bit more. But that's the question is how could you find that? Those are kind of the 2 methods of how you could do it. Okay, so if we actually do the check, one of these where you can actually solve this, in triangle ABC, Q is the centroid. So if Q is the centroid, and we know that we have medians, so we know that we have congruences out here that we can fill in. And then we also know that we have this 2/3 idea. So if BE is 9, so the full distance here is 9, then we know that from the vertex to that centroid is 2/3 of that. So 9 times 2/3. It's the same as doing the easiest way, I think, to do this is 9 divided by 3, which is 3 times 2, which is 6. So this is going to be 6 units. So BQ would be 6 units, and QE would be 1/3 of that, which would just be 3 units there. You can do this a lot of different ways. I like to just kind of say, okay, well then 9 divided by 3 is going to make this a 3, and then double that is over here, which is 6. Okay, but however you want to do that, that's what you're doing with it. So just another one here, you can see all the information given. Based on this information, you have these congruences. You know that's a midpoint connected to an opposite vertex, which makes that a median, and all of the other ones the same. So that makes this a centroid. So without telling you this is a centroid, all the information is there so that you know that. So then if they give you SP to be 3.5, you know that that's the one from the midpoint. So double that, which would be 7, is from the vertex to there. And then it asks for PZ, which is that. So that one would be 7. Okay. Okay, so altitudes of a triangle. Where do you think the orthocenter will be located in an obtuse triangle and a right triangle? So good questions here is that the centroid is always inside, but with an altitude, sometimes it's outside. So in a right triangle, it's actually going to be on the triangle. And in an obtuse triangle, it's going to be outside of the triangle. I did actually show you this picture on the very first day, but we'll talk about those a little bit more too. So an altitude of a triangle is a segment from a vertex of the triangle to the line containing the opposite side and perpendicular to that side. An altitude can lie in the interior and the exterior on the side of the triangle. So things to understand here is if you're looking at this ABC triangle and finding the height of the triangle, you go from the vertex perpendicular to the opposite side. Well, if you have this triangle here from the vertex, you can't go perpendicular to the opposite side inside the triangle. So what you do is you extend that side and you do your perpendicular to the opposite side outside of the triangle, and that's the altitude there. Okay, if you can imagine if this is a right triangle, how that works. Well, if this is B up here and you're going from the altitude, again, if this is a right triangle perpendicular to the opposite side, that altitude actually is this side over here. Okay, so those are kind of your three examples there of what it's going to look like. And that's just a single altitude. Now, every triangle has three altitudes. If extended, the altitudes of a triangle are concurrent, and the point of concurrency is called the orthocenter. So what we can see in this picture here is that we went from a vertex perpendicular to the opposite side, from a vertex perpendicular, from a vertex perpendicular. So that is three altitudes that all meet at a point, and that point right there is the orthocenter. Okay, and that's how I know that based on the drawing. So that is the information that you guys need for this one.